Welcome to our comprehensive tutorial on building a decentralized social network using Java. In today's video, we will explore the fundamental concepts behind decentralized applications, dive deep into the design and implementation steps, and write some code together along the way. Let's get started. First, let's understand what a decentralized social network is. Unlike traditional platforms that rely on a central server to store all user data, decentralized networks use a peer-to-peer system where users retain control over their data. This ensures privacy, ownership, and greater resistance to censorship. To build our decentralized social network, we will use several technologies, including Java for the backend and a simple UI framework. We will leverage existing libraries for peer-to-peer communication. In this tutorial, we'll implement a basic version that focuses on user registration, creating posts, and viewing others' posts. Let's start with setting up our Java project. We will use Maven as our build management tool. First, create a new directory for your project, and inside that directory, run the following command to generate a new Maven project. Once the project is created, navigate into the project folder. Now, let's open the project in our favorite Java IDE, such as IntelliJ IDEA or Eclipse. Next, we need to include dependencies for peer-to-peer communication and JSON handling. In the pom.xml file, add the following dependencies for AP2P library and JSON processing. You can use the above dependencies to handle JSON data effortlessly in your project. Now we can start coding. First, let's build a user class that represents the users of our decentralized social network. This class has two private fields, username and public key. The public key represents the unique identifier for each user in our decentralized system. Make sure to generate the getters and setters for these fields. Next, we will create a post class that represents a message or an update from the user. Each post will contain the content, a timestamp, and the user who created the post. The constructor automatically sets the timestamp when a new post is created. We will also need getters and setters for this class to access the data. With the user and post classes set up, the next step is to manage the users and their posts. Let's create a simple class called Social Network that will handle user registrations and post management. The Social Network class has a list of users and a list of posts. The Register User method allows you to create new users, and the Create Post method lets a user publish a new post to the feed. Now that we have a basic structure for our social network, let's implement a method to retrieve all posts for display. This method will be beneficial for displaying users' feeds. This getAllPosts method returns a list of all posts made on the network. Keep in mind that we will eventually replace the in-memory storage to work with a decentralized database or some distributed storage. Next, we can start imagining how our P2P network will work. For this, we will need to look for a P2P library. One common option is the lib2p library, but for our Java example, we will use something like peer.js, which provides a straightforward way to set up peer connections. You'd typically set up a signaling server for peer.js, which helps peers connect. You can run the peer.js server using node.js if you're implementing a hybrid solution. Though for this example, we will focus on a Java context. All right, moving forward, let's set up basic communication between peers. In a real scenario, this would include sending and receiving posts or updates. Here, we'll simulate sending a post to connected peers. The sendPost method would utilize the capabilities of the P2P library we're using to send a post to specified peers. In essence, each user in our decentralized network will listen for new content and update their data accordingly. So far, we've set up the basics of our social network. Next, we need to address a mechanism for retrieving posts that have been sent from peers. Each peer will need to have a listening mechanism to catch incoming data. Implementing this listener will ensure that users receive real-time updates when another peer publishes a post. This is what gives a decentralized social network its interactive nature. Now that we have the core components of our application written, let's visualize and test our social network model. You might want to connect multiple instances of your social network, running as separate applications on your machine. By running various instances of your application, you can observe how posts are sent and received. Each instance can be set to connect to peers, allowing for a lively simulation of a decentralized environment. Once we ensure that our basic functionality works, it's essential to think about the scalability and robustness of our application. Future improvements can include implementing a distributed database using a system like IPFS combined with database storage for user data. In conclusion, we have built the cornerstone of a decentralized social network using Java. We've learned about key concepts like users, hosts, and peer-to-peer interactions. As you continue to build on this foundation, think critically about how to expand and support more users effectively. Thank you for watching this tutorial. If you found this helpful, please hit the like button and subscribe for more programming content. Let us know in the comments what features you'd like to implement next or any questions you might have about decentralized applications.